This screencast will provide a brief overview of the CSAP concepts. For more material, refer to the training section of the reference guide. The CSAP management portals enable teams to manage their applications holistically. The application portal is the central management point. Some key features include launching teaming components, such as Grafana, or even Jenkins. Real-time metrics are available throughout the CSAP application portal. Here we see the aggregate cores collected as 10. If we click, we will actually see the detailed distribution of cores across the configured hosts. CSAP also provides trending views. If we look at the host resources, for example, we can see the same CPU cores represented across the last couple of weeks. It can be broken down by host and also into as short an interval as 24 hours. CSA records an extensive record of all machine and user activities. Categories can be selected, such as being able to highlight all the agent startups. The Deployment tab enables teams to interact with their application. Selecting the base OS cluster shows the services in the cluster. Selecting the CSAP Verify service shows all of the instances and the latest real-time metric collection for each instance. The Verify service is a Spring Boot service. To deploy it, we can simply select all instances, select Deploy. There we have an option of deploying from the mid instance or from the latest source code. In this instance, we'll just go ahead and deploy from Maven. This will automatically shut down all of the instances of the service, deploy the latest Maven jar, and then start them up again. Here you can see the deployment to all of the hosts occurring, and then once the updated repository is there, the service will be restarted. The CSAP Spring Boot integration plugin is responsible for starting the service, and we see the output of the arguments used. Clicking the logs again will actually show the output of the service itself. We can then select through any of the instances that we just restarted. CSAP supports the deployment of several runtimes. For example, it supports Kubernetes Helm deployments. So if we filter the clusters by Helm, select the Helm demo cluster, we see that we have Jenkins service deployed. CSAP README integration includes the actual integration of the Helm's README files. We can also see the resource files associated with this. The two primary resources are the Helm values file. You can see that we have a couple of customizations, including addressing a bug in the chart itself, as well as a standard Kubernetes persistent volume. The Host tab provides real-time reports on the state of the application host. We can sort by CPU test, for example, to highlight the difference that a standard CPU busy command takes. Here, we're seeing a pretty significant deviation in times, suggesting that some of the hosts have fewer or less up-to-date CPU cores assigned. Selecting the OS host view will show OS summary information, such as the version of the operating installed. Shown here, we have a combination of CentOS, Rocky, and Red Hat hosts. The host views also represent a convenient method for launching the CSAP agent portals available on every host. The CSAP agent host portal are focused exclusively on the host. These are really useful when diving into root cause analysis and troubleshooting of particular performance issues. The top++ view aggregates together dozens of OS commands based on a filter of the OS services that have been highlighted for focus. Unselecting the CSAP checkbox will show every service on the host, including the ability to quickly filter. The CSAP command runner is very useful in running commands, and it comes complete with a library of dozens of templates. By default, hitting run will only run that command on a single host, but we can quickly select multiple hosts and then run it and view the output on each one of those hosts. We can also quickly look at what's been happening on the host over the past hours. So currently there's a load test running and we're seeing the top 5 CSAP assets being collected. These graphs can be enlarged and of course filtered to have a focused view. The default view shows the last 4 hours, but we can quickly look at the performance over the last several days. The Project tab enables teams to configure every aspect of their application, including check-in and check-out from Git. The Environment view does the heavy lifting for applications by enabling the add, update, and delete of environments, clusters, hosts, and services. For example, filtering by Kubernetes shows the Kubernetes-related clusters, such as the Kubernetes provider, which has hosts assigned explicitly. Kubernetes System Services actually leverages the specified Kubernetes provider to deploy its service instances. All of the CSAP definitions start with a specification editor in which editors can free type in text, or by using form templates where services could be selected. The attribute view enables batch editing of the selected attributes. By default, we're looking at the description, but if we wanted to customize the start order of all the services, we can hit and select the field. The project view provides a hierarchical view of the application, along with direct access to the respective YAML definitions. Since this is only a demo environment, there's only 3 environments defined. Let's go and look at a little bit more interesting option. In the top left-hand corner, all of the environments are defined. We'll switch to another application with a large number of environments. This project has over 23 environments defined based on the needs of the individual team. You can note which of these are importing clusters, and you'll note that some of them have different sizes. This is a key component of CSAP reusability of application definitions. Define once, then refer and optionally override. Finally, we're looking at the file view, which provides direct access to the application Git repository that's associated with the application. This includes any service resources. For example, we were looking at Jenkins a little bit earlier, so let's filter this set of resources. And here are the same Helm values and storage file. And the final tab is the settings and tools. There's a number of settings in here that teams may decide to modify. One of the options is to have the navigation open on demand, so it's a little bit less intrusive into the navigational experience. This was just a very brief tour of the CSAP management user interface. Refer to the GitHub training wiki for a complete set of tutorials and demonstrations. Let's move on to the CSAP management concepts. The CSAP management domain extends across all application environments. This includes any custom or one-off environments needed by the application team. Capabilities including monitoring, logs, security, and audit are all in scope. The hosting domain, such as that provided by VMware, AWS, or Google Cloud, is out of scope and is typically managed externally. CSAP management enables teams to select from either existing environments or by adding their own. Out-of-box support includes configuration, deployment, and management of widely utilized artifacts, including Spring Boot jar files, Docker containers, Kubernetes YAML files, and Helm charts. Existing CSAP GitHub packages may be selected to include Prometheus and Grafana, Elasticsearch, and more. CSAP capabilities leverage the application definition. Managed as a Git repository, the application definition folder enables teams to compose their application. At the top level are projects, which are comprised of environments and services. There may be 1 to n environments. These include the relationship between both hosts and services. The final element are the service templates. Service templates are assigned to clusters. A cluster may be 1 to n hosts. Therefore, by dropping a service template into a cluster, 1 to n instances of the service are deployed. CSAP service definitions support flexible mapping strategy to OS services. For example, a single CSAP service may map to a single OS process. This is the case for the Dockerd agent, the kubelet agent, and the CSAP agent. CSAP services may also map to OS processes by leveraging a Docker container name. For Kubernetes, CSAP services may be mapped using container name, which may be a single container in a single pod, or a container name spanning multiple different pods. It also supports pod name regular expression. The CSAP provisioning pipeline enables teams to provision applications to 1 or more hosts using a fully automated process. This begins with a team member identifying the repositories required by the application. This includes creating a Git repository to store the CSAP application definition itself, and optionally Docker container image repos and OS repos. Next, the target hosts are identified and provisioned via the infrastructure provider process. The CSAP installer supports installation of 1 or more hosts concurrently. The installer installs the CSAP agent on each host. When the agent starts up, it may either create the default definition or connect to an existing Git to load the target definition. Using the definition, the CSAP agent then will deploy all services associated with the host. For Kubernetes services, deployments occur on the master only after the control plane and worker nodes have been started. CSAP service provisioning begins with a service definition. Cluster assignment associates the service definition with either specific hosts or host pools such as Kubernetes. The services are customized by specifying configuration maps of environment variables. These may include things such as data store URLs, load balancers, or any other environment-specific setting. The resulting service instances are then generated and then deployed by the management agent on each host. CSAP provides dozens of templates that are maintained and updated with each release. Key among these is the CSAP Docker and Kubernetes packages, along with CSAP Log Analytics, an Elasticsearch provider, and Kubernetes, a monitoring setup. The default templates are aggregated with any application templates to provide a rich capability set. Service definition attributes include everything from the deployment domain, things such as the start order, process parameters, artifact location, and much more. Attributes are further extended deep into the manage and operate domain. This includes things such as health alerts, performance metrics, as well as jobs which may be either on demand, as part of a deployment, or scheduled. Kubernetes service definitions support a variety of alternatives to meet different use cases. Creating a service may be as simple as a single Docker image name with optional configuration to customize Kubernetes spec generation. Alternatively, one or more YAML specifications can be added to the service definition and deployed. These standard specifications can be templatized with CSAP config map variables to manage multi-environment deployments. Sometimes a simple monitor may be useful when dealing with components created dynamically. CSAP management portals enable teams to define, operate, and manage their application across all life cycles and environments. The host portal is embedded in the CSAP agent installed on every host. The application portal provides a per environment view of the application. This includes environment deployments, alerting, auditing, trending, and much more. The analytics portal is multi-tenant. This includes views showing and comparing a specific application across multiple environments. For example, comparing QA environment performance tests to production levels.